Okay, so we are moving to the next topic. Now, this is about motional EMF. As the name suggests, it is about EMF generated by way of motion of a conductor. All right, look at this. I'll tell you the situation. We have a magnetic field which is into the board. These are into marks which represent what? Magnetic field that is into the board, right? Magnetic field can be represented either with dots or with into marks. Dot would mean what? Dot is out of the board, right? Whereas into mark is into the board. Got it. So I have a magnetic field which is into the board. How do you represent it? A magnetic field can be represented as B K cap with a negative sign. Why? Why with a negative K cap? Because to the right is called positive I cap, to the left is negative I cap. So we have 6 different axes, right? Okay, this is called positive x-axis. This is negative x-axis. And this is positive y. This is negative y. And out of the board is positive z. Into the board is negative z. So rightward direction is positive x-axis. Leftward is negative x. Upward is positive y. Downward is negative y. And into the board is negative z. Out of the board is positive z. Okay, so these are called coordinate axes. Coordinate axes. How do you represent them with vectors? I cap, j cap, and k cap. Okay, positive I cap means rightward. Negative I cap means leftward. And plus j is upward, minus j is downward. Plus k is outward, and minus k is inward. Okay, inward. That is why I wrote magnetic field as minus b k cap, because it is into the board, right? Okay, magnetic field is into the board. Now, in this, I'm keeping a rectangular frame. What is a rectangular frame? It's simply a conductor, like a copper wire, bent in the form of a rectangle. Bent in the form of a rectangle. All right. And I'm keeping a conductor on this. Look at the conductor. I'm just keeping a conductor on this. And I'm moving the conductor to a new location. Look at that. I'm just displacing the conductor to a new location. So I'll put the context one more time. Look at this. Okay, so we are talking about motional EMF here. Motional EMF, and it is nothing but EMF generated by way of motion. EMF generated by way of motion. It is called motional EMF, right? So we have a magnetic field here. Where does the magnetic field point to? It is into the board. Magnetic field is into the board, right? Into the board is what? Look at this one. Right word is positive x-axis, which is characterized by plus I cap. Left word is minus x-axis or negative I cap. Upward is positive j. Downward is negative j. Outward is positive k. Inward is negative k. All right. So I took my magnetic field where? Into the board. Into the board as per my figure, right? Into the board is minus k cap. Got it? Then what? Inside this magnetic field, I have kept a conductor like this, conductor. I'm moving the conductor now. I'm moving the conductor to the left. So this is conductor's new position, right? Correct. The conductor is moving to the left with a velocity v. What is the velocity? How do I write the velocity? I can write velocity as minus vi cap. Why minus vi cap? Leftward direction should be taken. Rightward is plus I. Leftward is minus I. Upward is plus j. Downward is minus j. Correct. So I attach velocity. I attach what? Minus I cap to it, right? As per the condition. You can even move the conductor to the right. Then you would take it as plus I cap. Got it? As per the figure, it is negative I cap. Got it? Now tell me what happens. All the electrons, you know one thing, that the conductor is made up of what? Billions of free electrons. If you take a conductor, there are free electrons inside, right? Free electrons. They are free to move anywhere inside the conductor. Correct. They will experience a force called Lorentz force. Lorentz force or magnetic force. Do you remember this from magnetic effect of current? Right. We learned it. A charged particle moving with a velocity v in a magnetic field B will experience a Lorentz force or magnetic force. F is equal to Q into V cross B. F is equal to Q into V cross B. F is equal to Q into V cross B. So I'm going to find out that force now. Look at this. What is the force on the electron? Charge of the electron is minus E. Charge of the electron is minus E. Electron's charge is taken E. but I would rather put negative sign. Why? Electron is negative. Into, this is V. V is what? Minus Vi cap cross. B is what? Minus Bk cap. Tell me what I'm going to get. This is minus or minus plus, right? Right. So tell me what I get now. Minus is outside. E into V into B into I cross K. Do you know what I cross K is? I have written this many times. If this is I cap, J cap, K cap, take them in the cyclic order, it's all positive. Anticyclic order, it's all negative. Correct. I cross K is what? I cross K is minus J, right? I cross K is minus J. So minus J. So you can take this minus along with this. Tell me what you get. EVB into minus or minus plus J cap. So my point is very simple. When you do this, the electrons will have a force. What is the direction of that force? Plus J cap, right? Plus J cap means plus I cap is to the right. Minus I cap is left. Plus J cap is up. So which means electrons will experience a force in the upward direction, right? So all the electrons will cluster around here. What will happen? The bottom end has lowest electrons, right? Correct. The electrons are flowing up. Why? Because they experience a force in the upward direction, right? So the top end is now negative, whereas the bottom end will be what? Positive. Because after losing electrons, this end becomes what? Positive. If I lose one electron, I'll become a positive charge. Correct. So bottom end is positive, the top end is negative, which means it acts like a cell. It acts like a cell. All right. Basically, this conductor has an EMF generated across it. EMF. That EMF is called motional EMF. Now, if you connect a bulb to this, the bulb will glow. Obvious, bulb will glow. Why? There is a current. Why? There is an EMF. No. Right. There is an EMF. So, basically, when the conductor moves, an EMF is created. That EMF causes a current, which actually causes the bulb to glow. This EMF is called motional EMF. Motional EMF. How to find the motional EMF? I'll do it again, don't worry. Motional EMF. Let us start off with the equation we learned yesterday. EMF is given by minus d phi by dt. Minus d phi by dt. All right. Minus d phi by dt. That is equal to minus d by dt of phi is equal to B into A. Yesterday we learned flux is given by B into area. Magnetic field into area. That is equal to minus d by dt of B into, tell me what the area is. This is the shaded area. If length is L and the distance is X, what is the area of the rectangle? Length into breadth, right? Correct. Area of the rectangle is length into breadth, right? This is the shaded area, which is in fact the area swept by the conductor, right? How much is the area? I can take it as length into breadth, L into X. So finally, B comes outside of differentiation. L is constant, that also comes outside. Then what do I have? dx by dt. dx by dt is called velocity. dx by dt is called velocity. That was taken in class 11. dx by dt is position is differentiated, you will get velocity. That is equal to minus B into L into minus V. Why did I put minus V? Because the conductor is moving to the left. Okay. And even modulus is fine, no problem. You can skip the negative sign if you want. So what do we get finally? Minus or minus plus BLV. B is the magnetic field strength. L is the length of the conductor. V is the velocity of the conductor. And this is supposed to be the most important derivation in this topic. Okay. Motional EMF, expression for motional EMF. Don't worry, I'll do it again. Now this part you don't have to learn. I just told you how it has an EMF developed. Understood? This is the derivation. That part is the derivation. Okay, I'll do it one more time. Look at this. See this one more time. I'll tell you the context. We have a magnetic field. This is a magnetic field that exists into the board, into the board, into the board, into the board, like this. We have a magnetic field that is pointed into the board. Got it? You can even do with out of the board also. That is up to you. Got it? Then what? You put a conducting rail. Conducting rail. This is like a conducting rail. How do you make a conducting rail? How do you make a conducting rail? You take a wire and bend it in this form. Take a copper wire and bend it in that form. You got a rail, right? Then what? On the rail, you will keep a conductor like this and you will push it to a new location. You are pushing it to a new location. Look at that. So basically, this is what you do. You put a conductor on the rails, then you push it to a new location. Got it? Got it. The conductor is moved inside a magnetic field. The conductor is moved inside a magnetic field. Basically, it needs to be a conductor. It needs to be a conductor. Conductor means what? Conductor means what? Something that conducts electricity, right? Copper, aluminum, gold, silver, any metal for that matter. Got it? Okay, you put a conducting wire on this, you move it to a new location. All right, that is the situation. Okay. And what all things you're writing first? I'm writing the magnetic field. What is the magnetic field? I can write it as minus BK cap. Why minus K cap? Like I said, right word is plus I, left word is, Namisha, this is for you, I'm repeating, Namisha. Right word is plus I, left word is minus I. Upward is plus J, downward is minus J. Right, we have like 6 coordinate axes. Right, right word is represented by plus I cap, left word is minus I cap. Upward is plus J cap, downward is minus J cap. Outward is plus K cap, inward is minus K cap. Right, you learned this already. Right. Here the magnetic field is where? Into the board, right? Into the board. Into the board means I must attach a minus cap, minus K cap, isn't it? That is how I wrote magnetic field as minus BK cap. Then how about velocity? Where is the conductor moving? I said it is moving to the left. Conductor is moving to the left. I took it as moving to the left. If you can take it as moving to the right as well. Understood? So I'm just pushing the conductor to the left. Instead, if you want to push it to the right, that's fine, no problem. All right. Okay, so it is what? It is minus VI cap. Minus VI cap. Why minus VI cap? Because right word is plus I, left word is minus I. Right word is plus I, left word is minus I. Got it? Then what? Now let us analyze what happens. When this is done, what's happening? Like I said, the conductor is full of free electrons. The conductor is full of free electrons. So each of the electrons inside the conductor will have a Lorentz force. Each of the conductor. Okay. What is the equation for Lorentz force or magnetic force? Do you remember the magnetic force? Q into V cross B. Q into V cross B is the equation for force. What are you talking about? Electrons, right? Charge of electron should be put here. What is charge of electron? Minus C. Right. And how about V and B? V is written there minus VI cap cross. B is written there minus BK cap. Tell me what you're going to get. This is minus E, then V is taken outside, B is taken outside. Minus or minus plus, right? Then what do I have there? I cross J, right? I cross K, right? This is what we wrote the other day. I, J, K. Look at that. I, J, K. If you take I cross K, look at that. You're going backwards, right? I cross K. It is what? Minus J. I cross K should be minus J, right? So that is minus J and the sign should be given to this. Tell me what now? EVB into minus of minus plus J cap. So now I know one thing. All the electrons experience a force. In which direction? Plus J cap direction. Plus J cap is where? Plus J cap means upward. Plus I cap is rightward. Minus I cap leftward. Plus J cap upward. Minus J cap downward. Plus K cap outward. Minus K cap inward. Correct. So all the electrons will experience a force. In which direction? Upward direction, right? So the electrons are moving up, up, up. All the electrons are moving up. So the electrons start clustering here at that end, right? All the electrons are going up, right? So the bottom end has lost electrons. It will become what? It will become positive. Now, will they keep moving forever? No. After some time, this will become so negative that it will prevent further inflow of electrons. Got it? When it is strong enough, it will start repelling electrons backwards. That is called equilibrium, the condition of equilibrium. Got it? The condition of equilibrium. All right, see, electrons are coming, it's going up. When electrons go up, the top end is negative, right? Bottom end, it has lost electrons, it's positive, right? Electrons are going in large numbers. They will start grouping there. Then what? Finally, it is so strong that electron coming will be repelled back. Correct? At that point of time, electrostatic force is equal to magnetic force. What is electrostatic force? QE. What is magnetic force? QVB. And Q and Q are cut. This E is actually equal to V by L. That way, cross multiply, you will get motional EMF as BLV, right? The same thing we derived just now. by another method. Understood? But I stick to this reader method. This is not the reader method. I just gave you an idea why we have polarity. One end is negative, the other end is positive now. Now that is acting like a cell. So if you connect a bulb here, the bulb will definitely glow because there is a current flow. Why? Because there is a potential difference developed. Why? Because it was moved in a magnetic field. All right. So this is called motional EMF. Motional EMF. So I'm going to derive it now. Motional EMF derivation. Look at this. This is how I do it. Motional EMF. I start off with Faraday's law. Minus d phi by dt. That is equal to minus d by dt of what is phi? Phi is equal to B into area, isn't it? Flux is given by B into area. Am I correct? Say something, please. All right. And area is what? Look at the shaded region. This is the area I'm talking about. Okay. Length of the conductor is L and the distance is Ex. So what is the area covered now? Tell me. Minus d by dt of, tell me, B into. Area covered is rectangular area, length into breadth, isn't it? Length into breadth. So that makes it what? L into X. I'll get that minus B outside, it's constant. L outside, it's constant. Then what I have is dx by dt inside, right? Now finally I have minus BL into dx by dt is called velocity. Dx by dt is called velocity. But it is moving to the left. I would rather put a minus sign on it, minus velocity. All right. So what do I get now? Minus or minus plus BLV. Motional EMF is given by BLV. Got it? Motional EMF is given by BLV. Or you can do this by this method as well. Electrons will keep flowing until what? Until the electrostatic force is balanced by magnetic force. What is electrostatic force? QE, right? What is magnetic force? Q into V into B. Got it? Q and Q are cut. But we know that electric field can be written as potential by distance. If you remember, cross multiply, motional EMF is what? BLV. Same thing you got here, right? Understood? You can write either of them for examinations, but better you stick to this because your teacher might be teaching this. All right. So let's start writing. All of you understood this? Everyone online? All of you online understood this? So let's do the derivation now. Just draw the figure motional EMF. Okay. Write this. Draw the figure. Right. We have a magnetic field which is into the board. Why into the board? You can even do it out of the board, but I prefer to take into the board for the time being. All right. We have a magnetic field which is into the board. The magnetic field is where? It is existing into the board, right? Okay. So let us write that magnetic field. How do you write magnetic field? Magnetic field is written as minus BK cap. Why minus BK cap? Tell me if you didn't understand. Minus K cap means inward. Plus K cap means outward. Correct. Plus I is right word. This is the fifth time I'm telling you today. Minus K cap is inward. Plus K cap is outward. Correct. Okay. Right. Then also put a rectangular frame here. A rectangular frame. This is the rectangular frame we are talking about, right? All right. Like a wire is bent in the form of a rail. All right. You will slide the conductor on it. You will put the conductor on it and slide it. Got it? So let us put the conductor right over here. Right. Then what? You're going to push it to the left now. You're going to push it to the left. So this is the conductor's new position. The conductor is moved where? Conductor is moved to the left. Okay? Okay? Right velocity. Velocity is where? I said it is moved to the left. You can mark it if you want. Velocity is to the left. To the left you attach minus I cap, minus VI cap. So I know my magnetic field is into the board. I also know that the velocity is to the left. Okay, let us analyze the situation. Okay. You can write. Imagine a conductor. Imagine a conductor. Imagine a conductor. Imagine a conductor placed inside a magnetic field. Imagine a conductor placed inside a magnetic field. Imagine a conductor placed inside a magnetic field. Imagine a conductor placed inside a magnetic field on a rail, R-A-I-L, on a rail as shown. Imagine a conductor placed in a magnetic field on a rail as shown. Okay, as shown. Full stop. When the conductor is moved, when the conductor is moved, when the conductor is moved, MOVED, when the conductor is moved, all the electrons, when the conductor is moved, all the electrons will experience, when the conductor is moved, all the electrons will experience, when the conductor is moved, all the electrons will experience a magnetic force, a magnetic force. When the conductor is moved, all the electrons will experience a magnetic force. So write the magnetic force. F is equal to, do you remember the equation for magnetic force? F is equal to Q into, whenever a charged particle with the charge Q moves with a velocity V in a magnetic field B, it is acted upon by a magnetic force. What is the equation for magnetic force? F is equal to Q into V cross B, isn't it? So let us put the values. What is Q here? Minus E, because we are talking about electron. Minus E into, this is V is what? V is minus VI cap cross B is minus BK cap. Okay. Tell me what you're going to get. That is minus E into V and B I take outside, V and B. What do I have inside? I cross K. Look at that. F is equal to Q into V cross B. Q is what? Charge of the electron. Charge of the electron. You know that the charge of the electron is minus E. I have written it there, no? Charge of the electron. Okay. Minus C into V is taken outside, B is taken outside, I cross K. Let us do I cross K on the margin. Just draw the figure if you remember this. I cap, J cap, K cap. Take them in the cyclic or anticyclic order. I cross K. They are talking about I cross K here, right? I cross K. What is I cross K? Look at the figure and tell me. I cross K. See this? I cross K. You're going backwards, right? Not in the cyclic order. It is anti-cyclic order. Am I correct? I cross K will be minus of J, right? So you get minus EVB into minus of J. So that will be EVB into J cap. So we know one thing, that the force is in J cap direction. Understand till here, all of you? Now what? What happens now due to this force? Tell me. See, I'm asking you, due to this force, electrons are moving in which direction? J cap direction, right? J cap means upward, right? So they will cluster at the top end. Am I correct? So the top end will become what? Top end will become negative. So having lost the electrons, bottom end will become positive. Top end is negative, bottom end is positive now. Am I correct? That looks like a cell now. One end is positive, the other end is negative. Correct? So you can write, due to this force, what will electrons do? Electrons will move up. Why up? Because J cap. Look at that J cap we calculated, right? Due to this force, electrons will move up, leaving the top end negative. I repeat, due to this force, electrons will move up. Okay, leaving the top end negative and bottom end positive. Top end is negative, bottom end is positive. That means two poles now, positive and negative, right? So that's like a cell now, right? An EMF is developed now. Am I correct? Voltage is developed, right? If you connect a bulb now, current will flow. Correct? All right. Now we can write. Thus, the conductor acts like a cell. Thus, the conductor acts like a cell. Thus, the conductor acts like a cell. The EMF generated this way, the EMF generated this way is called motional EMF. The EMF generated this way is called motional EMF. The EMF generated this way is called motional EMF. Okay. Basically, when a conductor is moved in a magnetic field, ends become polarized. Right. One end becomes positive, the other end becomes negative. Okay. The ends get polarities. Right. And this is known as motional EMF. The EMF is known as motional EMF. Got it? Right. So next line you can write. Motional EMF is given by, write this. You can use Faraday's law to do this. Motional EMF is given by motional EMF is given by E is equal to minus d phi by dt. Exact statement of definition is when a conductor is moved in a magnetic field, the ends of the conductor become positive and negative. The EMF generated is called motional EMF. Or in simple sentence, you can write the EMF generated on a conductor when it is moved in a magnetic field. Got it? You can write in your own words. See what happens here. What happens here? A conductor is moved. Where? In a magnetic field. And what has happened now? The ends have become positive and negative. You just write in your own words. Understood? The EMF generated on a conductor when it is moved in a magnetic field. That is called motional EMF. Got it? Right. Clear now? Okay, right. So let us put it now. Minus d by dt of B into, what is the area? Let us shade the area now. I'm shading it with yellow color here. Look at the shaded area. Let us call this distance as x and the length of the conductor as L. Tell me what the area is. Tell me what the area is. Area is length into breadth. Rectangle's area is length into breadth. So that is equal to minus B comes outside, L comes outside, dx by dt. Got it? So that is what? EMF is given by minus B into L into, what is dx by dt? Dx by dt was called velocity. Dx by dt was called velocity. I would rather put minus V because I was moving the conductor to the left. Even without it, it is fine. Okay, no problem. So, motional EMF is given by BLV. Put this in a box. When a conductor is moved in a magnetic field, the voltage developed across ends is given by BLV. All of you got it? Okay, so this is about motional EMF. What is motional EMF? The situation is this. We have a conductor like a copper wire. It is moved in a magnetic field. All right. When it is moved in a magnetic field, one end becomes negative, the other end becomes positive by the flow of electrons. Got it? And in short, it behaves like a cell or an EMF is generated. This EMF is called motional EMF. Now, how do we derive it? Like I told you, this is how I did it. We have a magnetic field that is into the board. Into the board, I call it minus K cap, minus BK cap. Okay. And the conductor is moving to the left. To the left means I put minus I cap to it. Right. Minus VI cap. Okay. And then I find the force on each electron. There are electrons inside. All the electrons will experience a magnetic force. What is the equation for magnetic force? Q into V cross B. Q into V cross B. Q I put minus C because we are talking about electrons in this case. And V is minus VI. B is minus BK cap. Minus or minus plus. And then V and B are taken out. Minus EVB into I cross K. I cross K is minus J. Minus or minus plus J. Which means magnetic force is in which direction? Plus J cap. Plus J cap means upward. So all the electrons are pulled upwards by the magnetic force. Got it? All the electrons are now reaching the top. So The bottom end is obviously positive now. One end is negative, the other end is positive. So that actually has polarized the conductor, right? One end is negative, the other end is positive, which will create a potential difference or an EMF or a voltage in simple terms. Got it? How to find EMF? It's very simple. Minus d phi by dt minus d by dt of B into A minus d by dt of B into area is length into breadth. Right? Length into breadth. L into x minus B into L into dx by dt. Dx by dt is called velocity. Since I moved it to the left, I put a minus V. So it is minus O minus plus BLV. So basically the condition is this. It should be moving in a magnetic field, should have a length L, and it should be moving with a velocity V. Then the conductor experiences conductor will have an EMF BLV. Look at this. I'm going to tell you a few questions now. Question number 1. Please. Question number 1. How is this asked in examinations? Like, they'll ask you to calculate the EMF generated between tips of the wings of an aeroplane. Tips of the wings of an aeroplane. Look at this. This is the wing. This is the wing of an aeroplane like this. I'm giving you a top view. Okay, top view like this. All right, between the tips, this point and this point. Because as the plane flies, it is cutting what? It is cutting Earth's magnetic field. Earth's magnetic field. Earth has a magnetism, right? I had told you that it is deleted now. Earth has a magnetic field. Even in this room, there is a magnetism for Earth. Got it? That is why if you keep a needle, that will stay in north-south direction all the time. Correct? Compass needle, right? Okay. So anyway, when the plane flies, they'll ask you to find out the EMF generated between tips of the wings. How to find it? B into L into V. What is B? Magnetic field of Earth will be given in the question. What is velocity? Velocity of the plane. What is length? Length is the wingspan of the plane. Wingspan. End-to-end length of the wings. They'll give you that. One wing will be maybe like 25 meters. So altogether that is 25 plus 25, 50 meters. They'll say it is wingspan. Understood? Wingspan will be given. Question number 1. Question number 2, I'll give you time to write. Don't write now. I'll ask you. Question number 2, imagine there are 2 rails like this. Rails. Railway track. Railway track. All right. Railway track. And this is one wheel on one rail. The other wheel is on the other rail, right? Correct. See, wheels are on the rails, right? And there is a rod connecting these two. That is called axle. This is one wheel. Look at me. This is one wheel. This is another wheel. And there is an axle in the middle. Axle. As the train moves, it is cutting what? Earth's magnetic field, right? Because anyway, the train is moving on Earth, right? Correct. Earth's magnetic field. So how do they ask the question? They will ask you to find out the motional EMF generated between the rails. There also motional EMF is what? Motional EMF is given by BLV. What is B? Magnetic field of Earth. What is L? The length of the axle. So there lies the catch. They'll say like meter gauge train. Meter gauge train. Meter gauge train is not the kind of train that you see nowadays. Like there was a small train like in the British era. That is called meter gauge train. Meter gauge means the distance between the rails is 1 meter. Even now it is running in Darjeeling, the toy train, or in Ooty, back in India. So the small train, no, it is much narrower than the original, the actual trains that are running. All right. So the trains are these meter gauge. If you see the word meter gauge, that means what? Rails have a separation of 1 meter, which means wheels have a separation of 1 meter, which means the axle has a length of 1 meter. So in this equation, if you see meter gauge, you have to put L as what? 1 meter. They won't tell you specifically, but if you see meter gauge, you have to put L is equal to 1 meter. Got it? That is the second thing. All right. I repeat one more time. Both these questions. Look at this. Look at this. The planes. First one is what? Like the motional EMF generated between the tips of the wings of a plane. Second one, the motional EMF generated across the axle of a train. All right. That is the second question. All these are previous board questions. We can check. All right. Third one, I'll tell you. Motional EMF, I wrote it as BLV. What is the equation for power developed on the conductor? Power developed. Do you remember this relation from class 10? Joule's law of heating. We wrote 3 equations. V square by R, V into I, or I square into R. There are 3 equations for power, right? So how to calculate the power developed? Power developed is E square divided by R. This E is BLV, the whole square by R. So what am I going to get? B square, L square, V square by R. So the electrical power developed on the conductor is B square, L square, V square by R. And the last equation, what is the force required? I can tell you one more time. Look at this. As I try to pull it to the left, somebody is opposing my movement. Who is opposing the movement? Lenz's law, yesterday I told you, know. When I try to push it to the left, the EMF generated will oppose the cause. Don't you remember? I repeat one more time. You know, when you try to push the conductor to the left, there is a backward force on it. Lenz's law opposes your movement, right? Lenz's law. As you try to push it, Lenz's law will prevent it. God will try to prevent it. So obviously, you need to apply a force to pull it, right? Somebody is resisting your intentions, right? So in that case, you will have to give a force. So tell me what? The force is given by power divided by velocity. Force is given by power by velocity. Power is what? B square L square V square by R by velocity. Velocity cut. B square L square V by R. Understood? These points are very, very important as far as exams are concerned. All right. We'll do the numericals now. There is one more coming up. I'll do that derivation later. Imagine you have a conductor being rotated like this. Rotated. Now, in this case, we move the conductor linearly, right? Linear motion. Look at me, don't write now. The conductor was moved linearly, right? What if I hold one end of the conductor and rotate it like this? There will be still motional EMF generated. For example, ceiling fan, leaf of a ceiling fan. Got it? Leaf of a ceiling fan. Ceiling fan, as it rotates, it is cutting Earth's magnetic field. Got it? It is cutting Earth's magnetic field. Or the spokes of a cycle wheel. Cycle wheel, no? Cycle wheel. Look at this cycle wheel spokes. These rods are called spokes of the cycle wheel. And spokes are rotating, right? Or the leaf of a helicopter fan. Helicopter fan, no? Or the leaf of the tail fan of a helicopter. All these are examples for rotating conductors. For rotating conductors, motional EMF is given by B omega L square by 2, where omega is equal to 2 pi into F. 2 pi into F. Omega is called angular frequency. F is the frequency. Number of revolutions in 1 second. This derivation I will do in the end. It is given in a box. Example question the reader. In the last 12 years, this question has come 9 times. 3 times consecutively on such 3 occasions. Understood? And it is one of the most important derivations in the whole syllabus. All right. I don't know whether your teacher has taught it or not, but you have to learn it. B omega L square by 2. Rotating conductor. Rotates. That they'll ask for sure. In Birla school, 100% sure they'll ask. I'm putting it on record. Okay. B omega L square by 2. They might not teach, but they'll ask. It is an important question there in the reader. Example question. All right. B omega L square by 2. In fact, it is the most important derivation. Most important derivation, most important numerical. I'll do it. B omega L square by 2. B is the magnetic field strength. Omega is called angular frequency. L is the length of the conductor. Length of the conductor. And a frequently asked question is this. They'll say like 10 spokes or 100 spokes. But in the case of cycle wheel, number of spokes won't be counted. Number of spokes. I'll tell you why. Because if you look at this spoke is connected between the center and the rim. This spoke is also connected between center and the rim. This one is also between center and the rim. This one between center and the rim. All spokes are connected between center and the rim. All right. Which means all are in parallel connection. In parallel connection, just check your knots from current electricity. You take cells like this. Okay. Now connect all the positives together. Connect all the negatives together. Even if you have 1,000,000 cells, you will have the effect of only one cell. In parallel combination, number of cells won't be counted. Number of cells does not have any significance. For this reason, in the case of a cycle wheel, that's a previous board question, cycle wheel, the spokes won't be counted. They might give you 10 spokes, 100 spokes, 1,000 spokes, 10,000 spokes, or even for 1,000,000 spokes, the motional EMF is still what? B omega L square by 2. B omega L square by 2. So, 100% sure, from this slide, you will have a 3-mark question board examinations. I promise. I can sign it on a paper if you want. All right. So, look at this. I'm 100% sure about it. Look at this. First is what? like I said, the derivation, motional EMF derivation, which we just did. Motional EMF derivation, this one. Motional EMF is given by what? BLV. Namaskar. BLV. Magnetic field is B. Length is L. Velocity is V. I'll tell you. So write down equations. Write down equations now. Number one. Equations. Number one. First equation. What is the equation for motional EMF? First one. Just now you derived motional EMF. And if you don't understand what I say, I am ready to repeat 1,000 times. No problem. It is up to you to ask me. Motional EMF. All of you online. So just write this down. Motional EMF is equal to BLV. What is B? Magnetic field strength. What is L? Length of the conductor. V is velocity of the conductor. Okay. Below which you write, in bracket you write, wings of plane. The questions can be wings of plane. They might ask like, what is the motional EMF generated between ends of the wings of a plane? Okay, ends of the wings of a plane. All right. Or they might ask you axle of train. Axle of train. Both questions are previous questions. Wings of plane. What will be the length of the conductor? The conductor is in fact the wing. In fact, the wings. Correct. So wingspan. I would call it wingspan. Wingspan means the total length of end-to-end length of the wings, right? That will be taken as length of the conductor. Got it? All right. Now, axle of the train. What will be the length of the conductor? Axle length, right? Look at this. These are the rails. These are the wheels. And this is the axle. Correct. Axle length is actually the length of the conductor. Got it? For meter gauge train, it is 1 meter. Meter gauge train. We'll do that question. Anyway, it is there. Meter gauge train, axle of train. Next one, power. Power developed. Power developed P is equal to, write this, power developed P is equal to E square by R. Write it. Power developed P is equal to E square divided by R. Power developed P is equal to E square divided by R. Write it. What is E here? BLV the whole square by R. How do you calculate the power? Power is given by V square by R or E square by R. This is called Joule's law of heating. Tell me if you have any confusions. Power is given by EMF square divided by resistance. Power is E square by R. All right. BLV the whole square by R. What is this? That is equal to B square L square V square by R. B square L square V square by R. Got it? Next one, force. Force on the conductor. Force, right? Force. Power by velocity. Force is equal to power by velocity. That is coming from class 11. If you want to know how, I can show you, but it is not needed. Force is equal to power by velocity. Force is equal to power divided by velocity. So what is power? Just now I written B square L square V square by R by V. V and V are cut. You get the force as B square L square V by R. Next one, rotating conductor. Yeah, numericals. Rotating conductor. These are equations to be used in numericals, okay? Rotating conductor. Draw the figure. We have a rotating conductor this time, okay? Motional EMF is given by motional EMF in that case is given by B omega L square by 2. I'll be deriving it later today. B omega L square by 2. Motional EMF is B omega L square by 2 for a rotating conductor. Rotating conductor can be like the leaf of a ceiling fan, or leaf of a helicopter fan, or the spokes of a cycle wheel. Okay. Last point. For cycle wheel, number of spokes is not counted. Number of spokes is not counted. Okay, so let me just start off from the beginning. I'll have a quick recap. Okay, I'll do a couple of questions. I'll take a short break. Right, look at this. This is where we started. Motional EMF. Okay, motional EMF. So what is the condition here? Like I said, we have a conductor. Where is the conductor placed? In a magnetic field. Just give me 1 minute. A conductor is placed in a magnetic field. Okay, again, a conductor is kept in a magnetic field. Where is it placed? It is placed on a rail. This is a rail, rectangular rail. And you are moving it now to the left. What happens now? By mathematics, we calculated that, we have found that the electrons are all moving up. Electrons are all moving up. So all the electrons would group around right here, leaving that end negative. Electrons are all negative, right? So that end is negative. So the bottom end has lost all the electrons. Bottom end is positive. So bottom end is positive, top end is negative, as per my conditions. Got it? If you draw a different figure, things will be different. Top end might be positive and bottom end might be negative. Got it? Anyway, one end is positive, the other end is positive, the other end is negative. Like a cell, like a cell. Look at the cell. The cell has what? The cell has a positive and a negative, right? The button at the top is positive and the flat side is negative. Got it? So in short, this conductor now behaves like a cell, with one end being positive, the other end being negative. Correct? Now, this is known as motional EMF. So in simple words, what is motional EMF? Whenever a conductor is moved in a magnetic field, one end becomes positive and the other end becomes negative. Got it? This creates an EMF. This EMF is known as motional EMF. Or if you are writing it in a much simpler way, generation of an EMF on a conductor when it is moved in a magnetic field. Generation of EMF on a conductor when it is moved in a magnetic field. Got it? That is called motional EMF. We even calculated the motional EMF minus d phi by dt. That is minus d by dt of flux is B into A. Yesterday we learned B into A. That is minus d by dt of B into, look at the yellow area, shaded area, length into breadth, L into X. So I get B outside, L outside, dx by dt inside. Dx by dt is velocity. That is minus of V because I move it to the left. So minus or minus plus BLV. So equation for motional EMF is what? B into L into V. B into L into V. All right. B is magnetic field strength. L is the length of the conductor. V is the velocity of the conductor. All right. Then I told you about this. When a plane flies, the wingspan, this is first wing, second wing, right? The wingspan, wings are cutting Earth's magnetic field, right? Wings are cutting Earth's magnetic field. Am I correct? All right. The wingspan, end-to-end length can be called wingspan. That will be taken as the length here. All right. In aeroplane questions. Okay. Or in the case of train moving on Earth, you know, this is one wheel, this is another wheel, and this is the axle connecting them. Got it? So when the train moves, the axle is cutting Earth's magnetic field, right? So there will be an EMF developed. What will be the length of the conductor? Length of the axle will be given in the question. Okay. Right. If they say meter gauge train, take it as 1 meter. The length is 1 meter. All right. Then I told you power developed. Power developed is what? Power is E square divided by R. E square divided by R. Or it is BLV the whole square divided by R. What is this? B square, L square, V square by R. That is the power developed on the conductor, or power needed to pull the conductor. What about force now? Force is power over velocity. Power is B square, L square, V square by R by V. V's are getting cut. You're getting B square, L square, V by R. Got it? And then finally, for a rotating conductor, I'll derive it later. If a conductor, one end is fixed and the other end is rotated like this. All right, like this. The motional EMF generated between the ends. What is it? It is B omega L square by 2. B omega L square by 2. B is the magnetic field existing. Omega is angular velocity or angular frequency. which is nothing but 2 pi f, right? F is the frequency. Number of revolutions per second, isn't it? And cycle wheel, in the case of cycle wheel, like I said, this is a cycle wheel. There are so many spokes now. Even if you have a billion spokes like this, all right, you got a billion spokes like this, all the spokes are between center and the rim, center and the rim, center and the rim, center and the rim, center and the rim. So all are like in parallel. In the case of parallel combination, number of cells won't be counted. So number of spokes won't be counted. Got it? So for such questions, do not count the spokes in. Got it? All right. Simply take b omega L square by 2 all the time, even if they give 10 spokes, 100 spokes, 1000 spokes, anything. Got it? All of you got it? Let's do one question. All of you understood now? So let's move the paper now. Take the paper. Question number 9. Read the question number 9. Read it. A conducting rod. Can you read the question? Question number 9. A conducting rod held horizontally along east-west direction is dropped from rest at a certain height near Earth's surface. Why should there be an induced EMF across the ends of the rod? Why should there be an induced EMF? Because when the conductor falls, it is cutting what? It is cutting Earth's magnetic field. Am I correct? Oh, tell me please. Earth has a magnetic field. Earth's magnetism or geomagnetism or terrestrial magnetism stands deleted now. It is not there. Got it? Earth's magnetic properties, that topic is deleted from magnetism now. Got it? But just know that everywhere, even in this room, there exists a magnetic field. So when a conductor falls, obviously, it must create an EMF, right? Why? It is intercepting a magnetic field. Whose magnetic field? Earth's magnetic field. Why? Because the conductor is falling on Earth's surface, right? Can you read the question again? A conducting rod held horizontally along east-west direction. Read it, please, for God's sake. Right. A conducting rod held horizontally along east-west direction is dropped from a certain height. Then why should there be an induced EMF across the ends of the rod? You can write, as the conductor falls, write it. As the conductor falls, tell me, it is cutting somebody, right? It is cutting who? It is cutting who? Tell me, cutting Earth's magnetic field lines, right? Correct. See, I'm teaching for the whole class. Everyone should tell me, okay? Right. As the conductor falls, it intercepts or cuts. Intercepts. That's a technical word. In simple language, you can write cuts. It cuts Earth's magnetic field. So, a motional EMF is created between the ends. Anybody wants it again? Look at this. They are asking why there is an EMF generated. Did you hear me? They are asking why, and no one is listening. Tell me what, why is an EMF generated? That is a question. It is clear because the conductor falls in Earth's magnetic field, right? Correct. So as the conductor falls, it intercepts Earth's magnetic field. Correct. Cuts Earth's magnetic field. Am I correct? That is why an EMF, emotional EMF is developed, right? Let us read the second part. Draw a plot showing the instantaneous variation of EMF. This was asked last year, BPS half yearly. Okay, instantaneous variation of EMF as a function of time. I'll tell you. Look at this. EMF, instantaneous variation of EMF. What is the equation for EMF? BLV. Am I correct? Am I correct? EMF is given by BLV. Look at this. They are asking you to write the instantaneous variation as a function of time. So I should introduce time in this. Look at this. I'll tell you. V is equal to U plus AT. Do you remember having seen this before? Yes. Final velocity is equal to, or velocity at any point is equal to initial velocity plus acceleration into time. First equation of motion. And it is starting from rest. Why? Because somewhere they are dropped from rest. Understood? 0 plus acceleration is G. For anything falling down, be it a raindrop or be it an apple, anything that's falling down, acceleration is G into T. So look at that. So I can write it as B into L into, look at V here, it is GT, right? I can put it here, B into L into GT. So I can say that EMF is directly proportional to time because B is a constant, L is a constant, G is a constant, E is directly proportional to time. So if you draw the graph, EMF of with the time, you will draw it this way. Got it? Because direct proportionality, the graph is a straight line. Got it? Got it? Right. Some internet resources give it with a negative time because acceleration they are taken as minus g. But this is fine, no problem. So the nature of the graph will be different, negative slope. Got it? It should be a straight line, that's it. So let us do that one more time. Write the second part of that question. Second part, EMF. Write the EMF. Write the EMF. EMF is given, but they are asking you to draw EMF, right? They are asking you to draw EMF. What is EMF? BLV. On the margin, you write this. V is equal to U plus AT, right? Velocity is equal to initial velocity plus acceleration into time. Initial velocity plus acceleration into time, right? That is final velocity is equal to initial velocity is 0. Why 0? Starting from rest. I said already, starting from rest. Correct. Rest means initial velocity should be always 0. Even otherwise, when something is dropped, Vaishnav, when something is dropped, you take the initial velocity as 0. Got it? 0 plus acceleration is g into time. So V is equal to g into time. Let's put it back here. E is equal to B L G T. So E is proportional to T. Draw the graph. EMF on y-axis, time on x-axis. You know that the graph is a straight line this time because direct proportionality is straight line. All of you online understood this? Anybody wants it again? Look at this. Hey, please, just before I do this, let me tell you something. When a plane flies, it is cutting, the wings are cutting vertical component of Earth's field, vertical component. In fact, Earth has two components. First one is vertical component of magnetic field, which is called B sine delta. Second is horizontal component of magnetic field, B cos delta. What is delta? It is called dip angle, will be given in the question. B is Earth's magnetic field. Delta is called dip angle, but they are deleted now. This is a previous question, but it got deleted last year only. Got it? But I have to do that question. They won't give it that way anymore. But here in this question, if you see, they have given you the dip angle also. They won't give it that way anymore. But since I included that in the paper, I'll do it. Okay. Don't worry. Nothing. Look at this. Look at this, Maria. Right. So when a plane flies, which component is being cut? Vertical. This is vertical component. Okay. Vertical component is being cut. All right. When the spokes of a wheel rotate, it is cutting horizontal component. Horizontal component. So just two cases. When a train moves, it is cutting vertical component. So the three cases. I repeat one more time. When the train moves, this is the axle. Axle, right? Axle. When the axle moves, it is cutting vertical component of magnetic field. Vertical component is what? B sine delta. When a plane flies also, it is cutting vertical component. Got it? If the plane falls down, it is cutting horizontal component. When the plane flies, it is cutting vertical component. When the spokes of cycle wheel rotates, it is cutting which component? Horizontal component. Horizontal component. So how to get it? BV is equal to B sine delta. BH is equal to B cos delta. Let me do this. A jet plane is traveling towards west at a speed of 1,800 km per hour. So speed is given. How much is the speed? 1,800 into 5 by 18. Why should I multiply with 5 by 18? Why should I multiply with 5 by 18? I'm asking you. Meter per second to convert to meter per second, right? So 18 cut, you're getting 500 meter per second, isn't it? So the speed of the plane is given, right? Length of the conductor. I had told you that it is wingspan, right? Wingspan. Correct? Yes. Where is wingspan? Is it given? The wingspan is given 25 meters. Wingspan is actually end to end length. Look at this. Distance from that end to this end. Understood? Both the wings together. Wingspan. Got it? So length of the conductor is given. Now the only thing that we need is B. Which B? Like I said, since the plane flies, it is cutting which component? Vertical component. This is called vertical component. Understood? Vertical component is taken which way? B sine delta. Correct? B sine delta. What is B? B is given there. Magnetic field is given there. 5 into 10 raised to minus 4. Sine delta is 30. Sine 30. So tell me what do you get? Sine 30 is 1 by 2. 1 by 2 into 5. 2.5 into 10 raised to minus 4. Now we can find the EMF using the equation. What is the equation? BLV, right? Correct? Yes. Motional EMF is BLV. B I have found out there. Tell me what it is. 2.5 into 10 raised to minus 4. Length is 25 meters. Velocity is 500 meter per second. Multiply, you'll get the final answer. Got it? You won't believe this question has come so many times in papers, like more than 10 times if you check. Same question with slight changes in data. Got it? Same question get repeated. So let us write it. Start writing. Start writing. Let's do it together. Okay? Just write this. Just write this. Just write this as a note before you start. Plane flies. Plane flies. Train moves. Both cases. Which component is intercepted? Tell me. The plane flies. When the plane flies, look at that. When the plane flies, it is cutting vertical component, right? Look at me, please. One last time, please. Vertical component. When the plane flies, it is intercepting vertical component. When the train moves, it is intercepting vertical component. Again, correct? How to get vertical component? B sine delta. Only case. Cycle wheel questions. Cycle wheel. Cycle wheel. Cycle wheel. Look at that. Cycle wheel is rotating. The spoke of a cycle wheel. It is cutting horizontal component, right? Horizontal. This is horizontal component. This is horizontal component. Cycle wheel moves. It is cutting horizontal component. Got it? Horizontal component BH is equal to B cos delta. All of you understood this? But I don't expect it to be asked this way anymore because that part is deleted. They'll directly give B. Understood? You don't have to calculate BV and BH. They'll give you BV and BH as is now. Because these equations are no more there in syllabus. They'll directly you can apply. Understood? But I can't take chances. So I'm doing it. Okay. Got it? So did you understand? See, Earth's magnetic field has two components. Which are they? Vertical component and horizontal component. Say it again. Vertical component and horizontal component. When the plane flies or when the train moves, vertical component is being cut. Correct? In the case of cycle wheel, the spokes are intercepting horizontal component. All right. BH is equal to B cos delta. BV is equal to B sin delta. Let's get to the question now. Shall I write this? BV and BH. Okay. So let us write this. First of all, write this. Write this on the margin. I want, this is plain question. So I want BV. BV is what? BV is B sin delta, isn't it? BV is equal to B sin delta, right? BV is B sin delta. What is this now? That is equal to magnetic field is given. Magnetic field is given here. Can you tell me what the magnetic field is? 5 into 10 to the power minus 4 into sine of, what is delta here? Angle is 30. Sine 30. So 5 into 10 power minus 4, 1 by 2. If you multiply, you get 2.5. So write the EMF. What is the equation for EMF? Motional EMF, BLV, right? It's in fact BVLV. Vertical component is right important, right? BV into LV, yeah, right. So what is BV here? BV I have found over there 2.5 into 10 raised to minus 4. Length of the conductor. I had told you that here the conductor is the wingspan, or the wings, right? So the wingspan should be taken length, 25 meters. Look at that, wingspan is given 25 meters, right? Into velocity. Velocity of the plane is 1,800 kilometer per hour into 5 by 18. You know why I'm doing this? 18 cut. You are getting 500 meter per second. Let's put it across 500 into 25 BLV. So 500 This is like 25 and 25, 625 into 3000 31,250 into 10 power minus 4. 1, 2, 3, 4. So answer is 3.125 volts. Got it? All of you understood this? Right. So what all things you learned so far? First concept was motional EMF. Whenever a conductor, I am repeating this for the 7th time now. Whenever a conductor is moved in a magnetic field, between the ends of the conductor, an EMF is developed. This is known as motional EMF. All right. One end becomes positive, the other end becomes negative. There is a voltage developed between the ends. All right. Again, a conductor is moved in a magnetic field. A conductor is moved in a magnetic field. Between the ends of the conductor, a voltage is developed or EMF is developed. All right. If you connect this to a bulb, the bulb glows because there is a current flow. Correct. This is called motional EMF, and motional EMF is given by BLV. B is the magnetic field strength, L is the length of the conductor, V is the velocity. B is the magnetic field strength, L is the length of the conductor, V is the velocity. If you remember, right. And then I gave all these cases, motional EMF, BLV. Two questions can come from that. One is the axle of the train question. Remember, axle length is actually the length of the conductor. For meter gauge train, take the length as 1 meter. All right, meter gauge, 1 meter. Usually back in India, we have broad gauge, 1.76 meters. All right, meter gauge has only 1 meter. That is why it is called meter gauge. All right, in questions, they give meter gauge all the time. So length is 1 meter. In the case of aeroplane, wingspan is the total end-to-end length of the wings. Okay, one end to the other end. All right, that is the length of the conductor. Then we learned power developed on a conductor. It is E square by R or B square L square V square by R, or power required to pull is also B square L square V square by R. Then force required. When you try to pull, somebody is opposing you. Lenz's law, right? By Lenz's law, the cause should be opposed, right? When you try to pull, somebody is opposing you. So you have to give a force, right? How much is the force? Power by velocity, B square L square V by R. Got it? Then I told you about a rotating conductor. A conductor is rotated in a magnetic field. Motional EMF is B omega L square by 2. I'll derive this in the next session, okay? Omega is angular velocity. It is 2 pi into F. 2 pi into F. Okay? L is the length of the conductor. And remember, in the case of cycle wheel, all the spokes are like connected in parallel. So number of spokes is irrelevant. All right, you won't count it in. Got it? Right. So let us do the question number 10 now. Make it quick. Let's take question number 10. Take the paper, take the paper. Figure shows a rectangular loop conducting PQRS. So this is the figure. If you are not able to see the figure, I'll draw the figure. Same figure we drew now. Correct. What kind of magnetic field? Into the board, into the board, into the board, into the board, into the board. Then what? A uniform magnetic field acts in the direction perpendicular. It is moved with a velocity v towards arm RS. Assuming that QR, RS, SP have negligible resistance. QR, RS, SP have negligible resistance. The rails are having negligible resistance. Obtain the expression for current in the loop, force, and the power. Current, force, and power. What is the equation for motional EMF? Look at this. What is the equation for motional EMF? Obviously, this is a case of what? Motional EMF. How do we know? Look at the figure and you know this. This is a magnetic field, isn't it? There is a rail, isn't it? And you put a conductor on it. Am I correct? Then you have pushed it. Am I correct? So this is a clear case of what? Motional EMF. Motional EMF. What is the equation for EMF? BLV. Don't do it now, please. They are asking you to find the current. How to find the current? Ohm's law will help you. E by R, right? Current is what? Ohm's law says current is voltage by resistance. So it is BLV divided by R. I'm done with it. Question number 1. All right. Question number 2. They are asking you to find the power. How to find the power? I already wrote it. E square by R. Correct. What is E square by R? After this, we will find force. They have given it in the wrong order because before finding power, you can't find force. Got it? Without finding power, you can't find force. Okay. They have given it in the wrong order. First, they gave force and then power. But first, you find power and then force. Force is power by velocity, right? Yes. Right. Let me do this. E square by R. That is BLV the whole square divided by R. So, B square, L square, V square by R. Got it? Then you have to find the force. Force is what? Power by velocity, which is B square L square V square by R by V. So V and V are cut, you get the final expression. Got it? Let us do it together. Write this. So what is given in the question? Do you read the did you read the question? Read it one more time. A figure shows a rectangular loop. This is a rectangular loop. All right. Conducting loop PQRS in which arm PQ is free to move. This arm PQ is free to move. That can move freely, right? To the left or right. Understood? This arm PQ is free to move to the left or right. Got it? I don't even have to read my question, right? This is something you've done already. 4 times I did. Then what? A uniform magnetic field acts in a direction perpendicular to the board, perpendicular to the paper, right? Magnetic field is acting perpendicular. Then arm PQ is moved. Arm PQ is moved. So it is clear case of motional EMF, right? Correct. So you can write, this is a case of all of you understood? All of you online, this is a case of motional EMF. This is a case of motional EMF. All of you got it? Everyone online? I'm asking the whole class. No one is responding. Motional EMF. This is a case of motional EMF. Right. So write the motional EMF. What is the equation for motional EMF? BLV. Say it once. That way you will learn. Motional EMF is BLV. B is magnetic field strength. L is the length of the conductor. V is the velocity. Got it? Now you are asked to find 3 things. Number 1, the current. Number 2, the force. Number 3, the power. Okay, let us do one by one. Number 1, current. Write current. How to find current? Current is given by Ohm's law. Current is equal to E divided by R. Correct? Ohm's law states that the current is equal to Ohm's law states that the current is equal to. So this is a case of motional EMF. E is given by BLV. Clear? Voila. Motional EMF is what? BLV. Moving conductor will create a magnetic field, right? B is the magnetic field strength. L is the length of the conductor. V is the velocity. Correct? So you can write one by one. Current is given by E by R. What is E? E is BLV. BLV by R. First part is done. Second part. They are asking you to find force. Instead, I find power first. What is the equation for power, Raji? E square divided by R, right? E square by R. Power is equal to E square by R. What is E? BLV the whole square by R. That is equal to B square L square V square by R. Okay. All right. The third question, we need to do one more question. Force. They are asking you to find force also. Force is equal to, how to find? We did it already. Force is equal to power divided by velocity, isn't it? Force equal to power by velocity. What is power here? B square L square V square by R by velocity. P and V are cut. You are getting B square L square V by R. All of you got this? Okay. Right. So let us do one more question. Okay. Finish this, right? All right. So let us do the next one. A rectangular conductor. Same question. Okay. Can you read the question and do it? A rectangular conductor LMNO is placed in a uniform magnetic field of 0.5 Tesla. So magnetic field is given 0.5 Tesla. It's basically the figure is the same as the previous question. The same figure we drew in the beginning. Do you remember the motional EMF figure? For those who are attending online, I'm just telling you, if you're not able to see the figure clearly, same as the first figure we drew today. All right, motional EMF. Then what is given? Magnetic field is given 0.5 Tesla. Then if the arm Mn of length is given, length is 20 centimeters. So how do you convert to meter? 20 into 10 raised to minus 2. Correct. Which is moving with the velocity is equal to 10 meter per second. These are not my questions. These are all previous board questions. Okay. All right. So velocity is what? 10 meter per second. Velocity is 10 meter per second. Calculate the EMF. You know what to do. EMF is given by what? BLV, isn't it? Isn't it? Motional EMF. What is B? 0.5. Length is what? 20 into 10 power minus 2. Velocity is 10. Nothing. You're talking about a conductor moving in a magnetic field. All right. Same question was asked in DPS last Monday. Same question. All right. Weekly test. Motional EMF is BLV. B is 0.5 into 0.5. Length is 20 into 10 power minus 2. Velocity is 10. All right. The same figure we drew in the beginning. So 0.5 into 20. That will be 10. 10 into 10. 100 into 10 power minus 2. 0, 0, 0, cut with this. That will be 1 volt. And they are also asking you to find the current. How to find the current? E by R, right? So 1 by resistance is 0.5. How do you know that the resistance is 0.5? E is 1. Yes, right. I mean, good. Then the current is also to be found out, right? What is current? How to find the current? You can use Ohm's law. Current is obtained using Ohm's law, right? Current is equal to EMF by resistance. Where is resistance? Resistance of the arm is given 5 ohm. You can put it across 1 divided by 5. That will be 1 by 5 is equal to 0.2 amps. Yes, correct. One last question, I'll wind up. Got it? Clear? Clear. 0.2 amps. All of you finish? Everyone online finish writing this? Oh, all right. Oh, right. EMF is given by BLV. B is given, length is given, velocity is given. And I put the values, I get it as 1 volt. And if I want to find the current, I take Ohm's law, EMF by resistance. Correct. All right. One last question there. This is the same question as the previous one. I'm giving it as homework to you. 13th question is homework. Let's do one question. 14th, I'll come back and do. Not 15th. 15th is easy, same question. The 16th question. A wheel with the 16. This is previous board question again. 16th question. A wheel with 8 metallic spokes. Does that matter to you? No. Okay, this 8 metallic spokes, it is irrelevant. Number of spokes is not to be counted, right? Be it 1 spoke, 10 spokes, 1,000 spokes, 10,000 spokes, even 1,000,000 spokes, answer will be the same. Got it? Got it? Yes. So let us write everything. Is rotated with a speed of 120 revolutions per minute. So first thing to do, 120 by 60. Why am I doing this? Revolutions per minute, tell me people, is to be converted to revolutions per second. How to convert to RPS? 1 minute is 60 seconds now. 1 minute is how many seconds? 60 seconds. So 120 revolutions per minute. They say 120 revolutions per minute. I need to get it converted to RPS. How? Divide that by 60. That will be 2 RPS. Got it? Why am I doing this? Now I can find omega 2 pi into F, right? Correct. Oh no. Frequency is what? The number of revolutions per second. Did you hear me? Frequency is number of revolutions per second. Number of revolutions per second. They have given revolutions per minute, RPM. RPM. What I need is RPS. So I'm dividing with 60. All the time you should do it. So 120 by 60, 2 RPS. Omega is equal to, tell me Kripa, what happened? 2 pi into 2, that is equal to 4 pi. Correct. Omega value you got. Then what? Here's magnetic field. Magnetic field is how much? Magnetic field is 0.4 Gauss. Gauss is 10 raised to minus 4. Yesterday I told you. 10 raised to minus 4. 10 raised to minus 4. Dip angle is 30. Dip angle, oh, not 30, 60, no? Dip angle is 60. Why have they given this? Because which component? Cycle wheel is cutting which component? Horizontal component, right? Right. But I believe they will give you directly from this year onwards. All right. But for the time being, let us not take chance. BH is equal to B cos delta now. BH is equal to B cos delta. All of you online? BH is equal to B cos delta, right? So that is equal to, what is B? 0.4 into 10 raised to minus 4 into cos 60. So 0.4 into 10 raised to minus 4. Cos 60 is 1 by 2. 0.2 into 10 raised to minus 4. Now you can write the equation for EMF. Rotating conductor, right? Rotating conductor, what is the equation? B omega L square by 2. Can you say it again? Rotating conductor, what is the equation? B omega L square by 2. B omega L square by 2. Correct? Rotating conductor, the equation is B omega L square by 2. B value is there, 0.2 into 10 raised to minus 4. Omega is there, 4 pi. Length of the conductor. Length of the conductor is that given? Where is it? 50 centimeter. Length of the conductor is 50 centimeters, which is actually half meter. Half meter. So half into half divided by 2. 2 and 2 are cut with 4. 0.2 and 2 are cut with 0.1. 0.1 and 10 raised to minus 4. 10 raised to minus 5 pi volts. Second part of this question. How will the value of EMF be affected if the number of spokes were increased? Will it matter? No. Nothing will happen, right? EMF won't be affected. So I'll do that very quickly one more time. Look at this. Magnetic field is given. What is magnetic field? 0.4 Gauss. Gauss is the CGS unit. Gauss is the CGS unit. Yesterday I told you Gauss is 10 raised to minus 4. 0.4 into 10 raised to minus 4 Tesla. Then delta, dip angle is given 60. I said cycle wheel questions, horizontal component is cut, right? So BH is equal to B cos delta. 0.4 into 10 raised to minus 4 into cos 60. Cos 60 1 by 2. Cut this with this 0.2 into 10 raised to minus 4. And frequency is 120 by 60, 2 RPS. Omega will be 2 pi into F, 2 pi into 2, 4 pi. And I put it back here, B omega L square by 2. Magnetic field here, omega here, length is half into half by 2. Solve it, you'll get the final answer. Okay, we'll continue with the paper in the next class. Shall we wind up for the day?